Hello all. In this video, we are going to see how we are going to define a task set for the software project. In the last two videos, we were talking about the basic concepts of project scheduling and tracking, the relationship between the people and the effort distribution. And here we are going to see how we are going to define a task set for software project. We've seen a number of different process models in the last modules, and this process model is populated by a set of tasks that enable a software team to define, develop, and ultimately support a computer software. No single set of tasks is appropriate for all projects. That is, the set of tasks that would be appropriate for a large and complex software or a system would be too big, or it would be perceived as a overkill for relatively small and simple software product. So, an effective software process should define a collection of task set, each designed to meet the needs of different types of projects. So, a task set is a collection of software engineering work tasks, milestones, and deliverables that must be accomplished to complete a particular project. And this task set to be chosen must provide enough discipline to achieve high software quality, but at the same time, it must not burden the project team with unnecessary work. So, the task sets are designed to accommodate different types of projects and different degrees of rigor. Degrees of rigor we are going to see later. Now, different types of projects that a software organization encounters. Okay. So, different types of project most of the software organization encounters are concept development projects, new application development projects, application enhancement projects, application maintenance projects, and re-engineering projects. Concept development projects means a new concept, a new business concept or application of some new technology is initiated, and such development projects are called concept development projects. Then we have new application development projects. New application development projects are again development projects, but they are undertaken as a consequence of a specific customer request. Okay, then the third type of project is application enhancement projects, and these occur when existing software undergoes major modification to function, performance, or interfaces that are observable by the end user. Then, fourth type of project is application maintenance projects. These projects are those projects that correct, adapt, or extend existing software in ways that may not be immediately obvious to the end user. And the final type of project that is encountered by a software organization is re-engineering projects. Re-engineering projects are that are undertaken with the intent of rebuilding an existing system in whole or in part. Okay, so that are the different types of projects that are encountered by the software organization. Another characteristic that a set of tasks depends on is the degree of rigor. Even for a project of a particular type, the degree of rigor with which the software process is applied may vary significantly. The degree of rigor is a function of many project characteristics. It is basically the how much effort that we are going to put into a project. That is the degree of rigor with which an application is developed. So this function may depend on many characteristics, like for small non-business non-critical projects, can generally be addressed with somewhat less rigor than large complex business critical applications. However, it should be noted that all projects must be conducted in a manner that results in timely, high quality deliverables. Okay, so there are basically four different degrees of rigor that can be defined. They are casual, structured, strict, and quick reaction. Okay, so the first one is casual degree of rigor. Casual means all process framework activities are applied, but only a minimum task set is required. That is, in general, umbrella tasks will be minimized and documentation requirements will be reduced. All the all basic principles of software engineering are still applicable. Such a project that works in this manner are having a casual degree of rigor. Okay. Then the second type of degree of rigor is structured. Structured means the process framework will be applied for this project. The framework activities and related tasks appropriate to the project type will be applied, and umbrella activities necessary to ensure high quality will be applied. Software quality assurance, software configuration management, documentation and measurement tasks will be conducted in a streamlined manner. So such a project that happens or that are applied in a structured manner are called are called to have a structured degree of rigor. And the third type of degree of rigor is strict. Strict means the full process will be applied for this project with a degree of discipline that will ensure high quality, and all the umbrella activities will be applied and robust work product will be produced. So here it will be structured, and the whole framework activities and all the umbrella activities, everything will be applied in a degree of discipline that will ensure very high quality. Okay. Then the final one is quick reaction. Here the process framework will be applied for this project, but because of an emergency situation, only those tasks essential to maintaining good quality will be applied. Backfilling will be accomplished after the application or product is delivered to the customer. Backfilling means developing a complete set of documentation, conducting additional reviews. Okay, so these are the four types or four degrees of rigor a project can have. Now we are moving into defining adaptation criteria. Adaptation criteria are used to determine the recommended degree of rigor with which the software process should be applied on a project. Okay, so there are basically 11 adaptation criteria that are defined for a software project. They are the size of the project, number of potential users, mission criticality, application longevity, stability of requirements, ease of customer or developer communication, maturity of applicable technology, performance constraints, embedded and non-embedded characteristics, project staff, re-engineering factors. So these are the 11 adaptation criteria, and each of these adaptation criteria is assigned a grade that ranges from 1 to 5. Okay, and here one represents a project in which a small subset of process tasks are required and overall methodological and documentation requirements are minimal. And 5 represents a project in which complete set of process tasks should be applied and overall methodological and documentation requirements are substantial. Now, computing a task set selector value. Okay. To select the appropriate task set for a project, the following steps should be conducted. Okay. First step is review each of the adaptation criteria and assign the appropriate grades 1 to 5 based on the characteristics of the project. And these grades should be entered into table 7.1. This is the table 7.1. So we have the in this table we have the adaptation criteria as the first column, then grade second column, third column is weight, then you have entry point multipliers, that is 1 to 5 entry point multipliers, and finally a product column. Okay, so what you have to do is, as a first step, you are going to review this different adaptation criteria and give grades for each of this adaptation criteria, which ranges from 1 to 5 based on the characteristics of the project. Okay, and this will be entered in this table. Then the second step, you review the weighting factors assigned to each of the criteria. The value of the weighting factor ranges from 0.8 to 1.2 and provides an indication of relative importance of a particular adaptation criterion to the type of software developed within the local environment. If modifications are required to better reflect local circumstances, they should be made. So as the second step, what you're going to do is you're going to review the weighting factors. That is a third column. You have some weights for each adaptation criteria. So these weighting factors ranges from value 0.8 to 1.2. Okay, so these values actually shows the importance of a particular adaptation criteria to the type of software developed within the local environment, and sometimes modifications will be required. If some modifications are required in this based on the local circumstances, then that should be made on this table. Okay, then the third step, you multiply the grade entered by the weighting factor and by the entry point multiplier for the type of project to be undertaken. Okay, so what you have to do is grade into weighting factor into entry point multiplier, and the result of this is placed in the product column of table 7.1. Okay, so here what we are doing, we have the grade, we have the weight and the entry point multipliers. You multiply this and the product is placed in the product column. Okay, so the entry point multipliers they usually have the value 0 or 1, and this indicates the relevance of the adaptation criterion to the project type. Okay, so when these three things are available, these three factors are available, you can find the values in the product column. And finally, you're going to compute the average of all entries in the product column and place the result in the space marked as task set selector. And so we have finally task set selector. There you take the average of all the values in the product column. Okay, and this value will be used to help the help select the task set that is most appropriate for the project. Okay, so how you are going to use this TSS, task set selector value? So once the task set selector is computed, the following guidelines can be used to select the appropriate task set for a project. That is, if the task set selector value is less than 1.2, then the degree of rigor is casual. If it is between 1.0 and 3, then it should have a structured degree of rigor. Then if it is greater than 2.4, then it should have a strict degree of rigor. So the uh, based on the TSS value, you are categorized, or we are going to select the different task set with different degrees of rigor. Okay, and you can see there is overlap in TSS values from one recommended task set to another, and this is purposeful and is intended to illustrate that sharp boundaries are impossible to define when making task set selections. Okay. In the final analysis, the task set selector value, past experience, and common sense must all be factored into the choice of task set for a project. Here's an example which illustrates how the TSS might be computed for a hypothetical project. Okay, so we have the table with adaptation criteria, grade, weight, entry point multipliers, and the product. The project manager selects the grade uh, uh, as shown in the figure in the table. So the project type is a new application development. So NDEF is the entry point multiplier. So the values in the entry point multiplier NDEF column is selected. So we have some values in the NDEF column. So these three values are taken, that is grade, weight, and the NDEF column is taken, and the entry to the product column is computed from this, that is grade into weight into uh, entry in the end of column or end of entry point multiplier. So that is the value of the product, and so the after filling the product column, you take the average of all values in the product column to get the task set selector. So that is how we compute the task set selector, and the here we get the value of task set selector as 2.8. Okay, so using the criteria discussed previously, the manager has the option of using either the structured or strict task set. Okay, so that's why the value that criteria has overlapping values. So here the manager has the option of selecting either structured or strict. Based the final decision will be made once all the project factors have been considered. Okay, so then selecting software engineering tasks. Concept development projects are initiated when the potential for some new technology must be explored. There is no certainty that the technology will be applicable, but a customer believes that the potential benefit exists, and the concept development projects are approached by applying the um, some of the following major tasks. Okay, so these are the major tasks, that is concept scoping, preliminary concept planning, technology risk assessment, proof of concept, implementation, customer reaction to the concept. Okay, this is just an example of concept development projects. Okay. First task is concept scoping. That means determining the overall scope of the project. Second is preliminary concept planning. That is establishes the organization's ability to undertake the work implied by the project scope. Then third is technology risk assessment. That means it evaluates the risk associated with the technology to be implemented as part of the project scope. Then third is proof of concept, which demonstrates the viability of a new technology in the software context. And fifth task is concept implementation. That means it implements the concept representation in a manner that can be reviewed by a customer and is used for marketing purposes when a concept must be sold to other customers or management. And finally, you have customer reaction to the concept. That it solicits feedback on a new technology concept and targets specific customer applications. Okay, so basically the software team must understand what must be done, that is scoping. Then the team must determine whether anyone is available to do it, that is planning. Then consider the risks associated with the work, that is risk assessment. Prove the technology in some way, that is proof of concept, and then implement it in a prototypical manner, so that the customer can evaluate it. That is concept implementation and customer evaluation. And finally, if the concept is viable, a production version or a translation must be produced. Okay. So this is a figure which shows a concept development task in a linear sequential model. So if a linear process model flow is chosen, each of these increments is defined in repeating sequences like this figure. During each sequence, umbrella activities are applied, quality is monitored, and at the end of each sequence, a deliverable is produced. With each iteration, the deliverable should converge towards the defined end product for the concept development stage. So this is all about selecting a task set for a software project. Thank you.